Hello, welcome to yet another section of the course, Mind Your Language. This section will cover the basic object Pascal language features and advanced constructs such as generics, anonymous methods, class helpers, custom attributes, and runtime type information, RTTI. Now we move on to the first video of this section that deals with Object Pascal. In this video, we are going to take a look at our console application and forms applications in Object Pascal. The simplest possible type of program that can be written in Delphi is a console application. It does not contain any graphical user interface. Console programs can be executed from the command prompt and can optionally take command line parameters. A console application may output some text back to the command line, perform some calculations, process files, or communicate with remote services running somewhere on the internet. Let's create a simple Delphi console app. It will be an interactive program that will take our name from the command line and will display a greeting. In the File menu, select New and Other. In the New Items window, make sure that the Delphi Projects node is selected and double-click on the console application icon. The IDE has generated a console application for us that currently does nothing. The first thing we always do after creating a new project is to save it. Click on Save All in the File menu. Click on the Save All icon in the toolbar or just press Ctrl plus Shift plus S on the keyboard. Always save a new project in an empty folder, so here I will create a new folder. Enter Greeter as the name of the new project and click on OK. Notice that the IDE has changed the identifier in the first line of the code and also the name of the file where the program is stored. Every Delphi executable program source code needs to start from the Object Pascal keyword, program, followed by the name of the program. The name of the program should match the name of the file it is stored in. The identifier in code should match the physical file name, otherwise the compiler will fail to process the file. If you now browse the folder where the project is saved, you will find two files, named Greeter but with different extensions. Let's see our files. One is the greeter.dpr file that contains the source code of the program that we see in the code editor. The second one is the greeter.dproj and contains the MS-build XML code that the IDE uses for storing different settings belonging to the project that are used for compilation. By convention, the main file of the Delphi app, the one that starts with the program keyword, does not have the .pas extension, but .dpr, which stands for Delphi Project. Let's make some changes to our program. Declare a variable, then write the messages for the user. Save and run the application. It should display an Enter Your Name message and then display the welcome message. So I will enter my name as Delphi. Procedures for reading and writing to console come from the built-in system unit, so in our simple demo program, there is no need for a uses clause at all. The last empty readln statement is there in the program, so we could actually see the output from the previous writeln statement before the program closes. Write is used to output text to the console, and read is used to read the input from the console into a string variable. The writeln and readln variations of these methods additionally advance to the next line in the console. Before the begin keyword, there is a variable declaration. Object Pascal is a strongly typed language. You need to declare a variable and its type before you can use it. In our example, S is declared as string, so it can hold an arbitrary string of Unicode characters. Traditionally, in the Pascal language, the individual characters of a string can be accessed with a 1-based index. Delphi mobile compilers follow conventions used in other languages and use a 0-based indexing. There is a special compiler directive, 0-based strings, that can change this behavior. The code editor helps us in a visual way to work with our code. Here on the left-hand side, in the gutter, there is a green line. It is completely green because I just saved the code. If I start typing, the color of the gutter next to the modified row will change to yellow to indicate that there are some unsaved changes. Every time you save a file, its local copy is stored in a hidden _history folder. At the bottom of the code editor, there is the History tab. In the History view, you can browse through changes, compare file versions, and restore a file to a previous revision. Blue dots in the gutter indicate all executable lines of source code. This is where you can place a breakpoint if you want to debug this program. The instructions that make up the Object Pascal program start with the begin keyword and end with the end keyword, followed by dot. Everything that goes between them contains statements. Each statement is separated with a semicolon character. It will still be a valid program if we remove the semicolon after the last read ln instruction, because the semicolon's role is to be a separator and not a terminator. The indentation of the source code and text formatting does not have any meaning for the compiler, but it is good practice to use indentation and empty spaces for better readability. That is why the begin and end keywords start from the beginning of the line and all the other statements are indented. To increase the indentation of a block of code in the code editor, select the lines, keeping the Shift key pressed, and use the Ctrl plus Shift plus I key combination. To decrease the indentation, use Ctrl plus Shift plus U. You can put arbitrary text in your source code in the form of comments, which are ignored by the compiler. Comments are multi-line or single-line. Multi-line comments are enclosed within curly braces or a bracket and star character combination. These two types of multi-line comments can be nested within each other. Some multi-line comments start with a $sign. They are displayed in a different color in the code editor because they are compiler directives. In the default source code generated for a console application, there are two optional compiler directives. The first one tells the compiler that this program is a console app, and the second one, with the R switch, instructs the compiler to embed in the resulting executable any binary resources that may be found in the resource file with the same name as our project, but with the .res extension. Single-line comments start with 2 slashes. A compiler ignores all the characters that follow until it encounters the end of the line control characters. If you want to quickly comment out or in a block of code, use the Ctrl plus / key combination. If a comment starts with 3 slashes, it is treated as a special documentation comment, which can be used for displaying documentation hints in the code editor and documentation generation. It is a good practice to properly document your code with comments, so it is easier to read and maintain it. It is time to start building our first fully functional mobile app, the Game of Memory. In this section, we will only create the main architecture. Our app is going to be very simple. There will be 2 forms. One main form will contain a grid of squares, which will serve as the game board, and the second form will contain the game settings. The simple architecture will help us understand the structure of a typical Delphi Forms application. Now close the greeter program if it is still open. Create a new multi-device application, Delphi program. Select the blank application template and click on Save All. Save the file that contains the main form of the application as uform-main and the project as Game of Memory. Save the project. Change the name property of the application form to form-main. Add another form to the project. In the File New menu, select Multi-Device Form, Delphi. In the dialog to select the form type, keep the default HD selection. The other option is 3D. We will get to building 3D user interfaces later in the course. HD stands for High Definition and is just a more fancy way of specifying that we just want a regular 2D form. Save the file as uform settings and change the name property of the new form to form settings. Our project contains 2 forms now. Where is the program file of our app? Click on the View Source option in the Project menu or in the Context menu in the Project Manager. You should now see this code here. This is the main program of our Game of Memory app. The main program file in our project is managed automatically by the IDE, and in most cases, there is no need to edit it manually. This is a very typical project file. The first line contains the program heading. The lines following it contain the uses clause. Next, there is a compiler directive links the resource file of the project into the program. What follows is the block of statements executed when the program runs. The project file ends, like all the source code files, with a period. The uses clause lists all the units incorporated into the program. These units may in turn have their own uses clauses. The logic of a program is defined between reserved words, begin and end. In this program, executable statements are simply method calls to the global application object of the project. The block can also contain declarations of constants, types, variables, procedures, and functions. These declarations must precede the statement part of the block. The Delphi code editor has a built-in hypernavigation functionality to quickly jump to other units. For example, we may want to see where the application global object variable reference is declared. If we move the mouse cursor over application somewhere in the code, we will see a hint that tells us in which unit a given symbol is defined. If you press the Control key at the same time, the symbol turns into an underlined hyperlink that you can click to quickly jump to the unit where a given symbol is declared. Alternatively, you can right-click on the symbol in the editor and select the Find Declaration option. The blue arrows in the IDE toolbar let you move back and forth through the history of your navigation in the code editor. The call to create the settings form, depending on the processor speed of your mobile device, may delay the moment when the end user sees the screen of the app by a couple of milliseconds. We can just manually delete the line of code in the code editor that contains application.createForm, tform settings, form settings. But there is a more elegant way of doing so. In the project menu, click on Options, the bottom of the menu. In the Project Options dialog, select the Forms node and move Form Settings from the list of Auto Create Forms to the list of Available Forms. Note that the line of code responsible for creating the Settings form disappeared from the main program block. Now we are going to implement basic navigation between the forms and at the same time have a closer look at the structure of the object Pascal unit. The main form of the application is displayed at Application Startup, and its lifetime is the same as the application. Let's add a toolbar to the main form of the app and a speed button in the top right corner, which will display the settings form. In the settings form, we will also add a speed button on the left-hand side of the toolbar with the left arrow image for going back to the main application form. Make sure that the form main unit is open in Form Designer. If you are in the code editor, you can switch to Form Designer by clicking on the Design tab at the bottom of the screen. Press the Ctrl and Dot keys at the same time to focus the IDE insight and just start typing T toolbar that we want to add to the form. After the first three letters, the T toolbar should be at the top of the list. Just press Enter to add it to the main form. It will automatically align to the top of the form. In the same way, using the IDE Insight, add the T Speed button component on the toolbar. Change its Align property to Right so it always stays in the top right corner of the screen, regardless of its size or orientation. Change the Name property of the Speed button to SPD-BTN Settings. Now we need to give it a nice icon. We can do it by changing its Style Lookup property. You can select any of the SPPP Up tool buttons. Here I am selecting the arrow up. By default, when we create a new multi-device form, it uses the default Windows style. What we really want is to see how the form will look on a mobile target, be it iOS or Android. Change the selection from Windows to iOS in the combo box above Form Designer. Now if we open the Style Lookup property of the Speed button in Object Inspector, we should be able to select from one of the built-in iOS styles for a given control. Select the Draw Tool button style from the list. If we switch to Android, the look and feel of the form will change, including the styling of the toolbar and also the icons available for styling the Speed button. Save the form. Now go to the Settings form. Change style in the preceding combo box of the form to iOS. Following the same steps, add a toolbar and a speed button. Change the name property of the speed button to SPD-BTN Back, its style lookup property to arrow left tool button, and align property to left. Now we will implement the functionality to navigate between these forms. In the main form, when we click on the Settings button, we want to call the Show method of the Settings form. However, Form Main does not know about form settings. We need to add form settings to the Uses clause of Form Main. We could do it manually, but the IDE again can help us with it. Make sure that the uform main file is open in the code editor and click on the Use Unit option in the File menu. In the Use Unit dialog, select Form Settings and keep the default selection to add this unit to the Uses clause of the implementation section of the Form Main unit. This dialog will list all the other units in the current project that are not yet used by the currently selected unit. The next step is to do the same thing in the form settings. Add Form Main to the implementation section of the Uses clause of the form settings. Double-click on the Back Speed button and enter one line of code to show the main form of our application. Here we will type for main.show. This is a fairly simple object Pascal unit. Every unit file begins with a unit heading, which is followed by the interface and implementation sections. After the implementation section, there could be optional initialization and finalization sections with instructions to be executed before and after the main application logic. The interface section of the unit starts with the reserved word interface and continues until the beginning of the implementation section. The interface section declares constants, types, variables, procedures, and functions which are visible to other units in the project. The interface section does not contain any executable code. The declaration of a procedure or function includes only its heading. The block of the procedure or function follows in the implementation section. The interface declaration for a class includes declarations of all its members, including the ones that are private to the class and not accessible to the code outside the declaring unit. The interface section may include its own uses section, which must appear immediately after the interface keyword. The implementation section of a unit starts with the implementation keyword and continues until the beginning of the initialization section, or, if there is no initialization section, until the end of the unit marked with the end keyword, followed by a period. The implementation section contains declarations of constants, types, variables, procedures, and functions, which are visible only to the declaring unit. This introduces better organization to the program structure through encapsulation and separation of concerns. The implementation section of the unit contains the executable code defined in either standalone functions and procedures or belonging to classes, and in this case called methods. Only those functions and procedures that additionally have their headings declared in the interface section of the unit are visible to the code residing in other units. The implementation section of the unit may have its own Uses clause section, which follows immediately after the implementation reserved word. A given object Pascal unit may contain a reference to other units only once, either in its implementation section or its interface section. If you are unsure where to put a unit reference, always use it in the implementation part of the unit. Sometimes you have to put a unit reference in the interface section of the unit. For example, our uform settings unit declares the tform settings class type, which inherits from the tform class, which is defined in the fmx.forms unit. So this unit has to be listed in the interface section of the unit. If unit A depends on unit B and unit B depends on unit A, then they are mutually dependent. This is the case between the two units in our Game of Memory project. If the two units are mutually dependent, at least one of them should list another in its implementations and not interfaces uses clause. The initialization section is optional. It starts from the initialization keyword and continues until the beginning of the finalization section, or if there is no finalization section, until the end of the unit. The initialization section contains statements that are executed at the program's startup. The order in which the units are listed in uses clauses is important because it is what determines the order in which initialization statements are executed. The finalization section is also optional and can only appear in units that have an initialization section. It starts from the reserved word, finalization, and continues until the end of the unit. The finalization section contains statements that are executed when the program terminates. The finalization sections are executed in the opposite order of initializations. The uForm settings unit contains the declaration of the tForm settings type. Type declarations follow the reserved word type. After the declaration of the form's type, there is a variable declaration, form settings of the tForm settings type. Variable declarations start with the var keyword. When you define a variable, you must also state its type. The object Pascal language is strongly typed. The more complex your programs begin, the more you will appreciate the fact that it is not the job of a compiler to guess the type, but it is you, the programmer, who decides about types. The Delphi compiler works in a top-down fashion and typically just makes one go through all the dependent units in your project. Inheritance is a very important concept in object-oriented programming. Our settings form has everything that a standard multi-device form has. You can inspect the declaration of the tForm class in the fmx.forms unit. A class declaration defines the name of the class and the class it inherits from the in the brackets after the class keyword. The class declaration is divided according to visibility. Different class members can be private, then they are visible to the defining class only. It is also possible to have members defined as protected. This means that a given member, variable field, constant, or a method is also visible to the descendant classes. The two other important visibility specifiers are public and published. The first one means that the class members are visible to all the other units in the project. Published has public visibility, but additionally published class members are also accessible at the design time in the IDE. The 3 lines right after the class declaration of the form contain 2 field declarations for the toolbar and for the speed button. There is also a method, or more specifically an event handler, for the on-click event of the button. These declarations do not have an explicit visibility specifier, and they are treated as published. This part of the form class is managed by the IDE. Every time you add a component to the form or create an event handler, the corresponding declaration is added automatically. Also, the interface uses clause is updated by the IDE every time a different component is added to the form in Form Designer. The form's class declaration also has placeholders for optional private and public declarations that the programmer may want to add. The implementation section of the unit starts with the $R compiler directive that instructs the compiler to link into the unit the form file that is managed by the IDE and contains component properties set by the form designer and object inspector. What follows is the implementation of the tForm settings.speed button back-click open brackets sender to object close brackets event handler. Its name is made of 2 parts separated by a period. The first part is the name of the class and the second part is the name of the method. In brackets, there is one sender parameter that is passed to the method and in this case is a reference to the speed button back control of the form. The show method in the body of the event handler has been inherited from the tForm class and as such is available in the descendant tForm main class reference defined in the other form. One last thing is to implement the functionality to show the settings form in the on-click event of the main form. Remember that we have removed the tForm settings from the list of auto-created forms. This means that we are now responsible for creating an instance of this class before we can manipulate it in code. Let's enter the code in the on-click event handler of the SPDBTN settings speed button. So go to the event handler, click on Designer tab and double-click on the speed button. The global form settings variable stores the reference to an instance of the tForm settings class. We only need to create the settings form once in code. This is a common lazy creation pattern, where an object is created just before it is used for the first time in code. If the end user never clicks on the settings button, this object is never created. Here we are entering a whole new world of different expressions and instructions of the object Pascal language. In short, what happens here is that if the form settings variable is nil, then we assign to it the reference to the newly constructed instance of the tform settings type. Create is a special constructor method that may perform the initialization of an object, but most importantly, it allocates memory for the object. There are also destructors that are responsible for freeing the object's memory. The tform class, which is an ancestor to tform settings, is in turn inherited from the tComponent class. This is where the create constructor is defined. Here we specify that the global application object is the owner of the newly created form, and it will be responsible for calling the form's destructor when the application is terminated. We learned to code in Pascal here.